is for your modeling and investigating watersheds activity. So on your lab sheet, you're going to see a drawing. Right here, it's figure 1 that represents this. This is laid out the same way as your drawing. So the first thing you need to do is to put the underlying features in order from highest elevation to lowest elevation. So here is Eagle Point. Here is Deer Ridge. Over here we have Canyon Lake. This is Lake Hill. And then Oak Run River goes down through the middle. Then you have a couple questions. So number 3, what do coastlines indicate on a topographic map? So use your topographic notes to answer that question. Now 4, 5, 6, and 7, you're going to look at your box A and your box B. Box A, you need to take a second right now and pause the video to predict the water path when water will be dropped from this pipette above Eagle Ridge. I'm sorry, Eagle Point. So Eagle Point is right here. So predict the water path, or the path that water is going to take when the water is dropped from right here. So again, hit pause and make that prediction, draw that on box A. So right now I'm going to go ahead and drop the water over Eagle Point. So again, now you're going to, on box B, draw the actual path of the water. And that is number 6 with the blue pencil, if you have a blue pencil. And for number 7, it says use the red pencil to mark the topographic features that caused the water to take the path that it did. We're talking about topographic features. What shapes or landforms here caused the water to move the way that it did? So if you remember, the water kind of took a curved path there. Sorry, that's a little fuzzy. So you see the water, it's curving, it's splitting here and then going down the river here. So shade in with red which topographical features did that. Okay, now for 8, you're going to repeat these steps. We're going to do it for Deer Ridge, which is right here. And you can see the little dot where we're going to drop that water from. And also Lake Hill, which is right here. So make your predictions. Again, what's going to happen when we drop water right here? Where's it going to go? This is Deer Ridge. And Lake Hill, where's it going to go? So on your lab sheet for Eagle Point, here's your prediction. There's your actual. And for Deer Ridge, here's your prediction. Draw where you think the water is going to go. You'll mark your actual here. And for Lake Hill, prediction actual. So again, hit pause and make those predictions. Okay, now we're going to drop the water over Deer Ridge. So see the path that it takes. As you can see, most of it is going down into Canyon Lake. Now for Lake Hill, and you can see at Lake Hill, you have most of it going into your river, but none going into the lake. So make sure you mark what actually happened here and here on your sheet. Okay, now we're going to talk about number 11. So it says a gasoline tanker truck wrecked on Deer Ridge during a heavy rainstorm. Make a dot with the water base marker to represent the gasoline. Gently release 2 pipettes of water over the gas spill and observe the water flow path. You need to tell me which part of the watershed was impacted most from the gasoline spill and support your answer. So we can see this is on Deer Ridge. That blue dot is going to represent our gasoline spill. So I'm going to release 2 pipettes of water and you can observe what happens. So you can see where did most of the gasoline go? Into Canyon Lake. So now number 12 asks about a mining company that discovered a coal bed, which would be a large layer of coal at the top of Lake Hill. Your town wants to determine the impact of a mining operation on the water quality of Oak Run River and Canyon Lake. Use your water-based marker to represent the sediment that would be created and the coal that would be exposed during the mining operation to determine the impact on both Oak Run River and Canyon Lake. So here's Lake Hill. This is where the coal bed would be, and we're just going to release some water over it. And for number 12, you just need to briefly describe what happens, what the impact is on Canyon Lake here, and what the impact is on Oak Run River. So where is most of this sediment left over from the coal mine going to go? You can see that most of it is going into Oak Run River, so that's the part of the watershed that will be the most impacted by the mining activity. I'm just going to go over some of the questions on here and show you some examples of anything you might need to answer the questions. First, what determines the boundary between two watersheds? Give a specific example from the activity. So if you look, I've marked all the high points on this watershed. So that means along this area, that is going to divide where the water goes. So whenever you drop water along these areas, half will go to one side and half will go to the other. Remember, a watershed is an area where all the water goes to the same place. This would be that Oak Run River. So anytime water's dropped here, some is going to go down here and some is going to go to the other side, which would be a separate watershed. And again, you see over here, if the water's dropped here, some goes to one side and some is going to go to the other. So it's those higher elevations that determine the boundaries of your watershed. Now number 2 asks, is this entire model part of the same watershed? We just kind of answer that with number 1. As you saw, when we dropped over the higher elevations, you saw the water go to different areas on the outside. Anything around the outside where the water goes to would be a different watershed, so there would be definitely more than one watershed in this model. Number 3, which feature on the watershed model do you think experienced the most weathering? Weathering would be wearing away by natural processes such as moving water. So I'm just going to dump some water in here at Canyon Lake, and you can think, okay, which part of this watershed is going to experience the most moving water and keep getting worn away? So this is a constant flow of water. Everything else will get touched by precipitation, but where we're going to see the most moving water is definitely in our river. On figure 1, you need a red pencil or just a pencil to mark the boundaries of your watershed. So remember, we just talked about around this area, around your high points of elevation, that's going to cause your watershed to be divided from other watersheds. And again, we call those divides. 5, 6, and 7 can be answered using your topographic map. And you can see here that's 40, 50, this is 60, this would also be 60, and then 70. You can use your topography notes to help you with that. 8, other than the tanker truck spills and coal mines, list 3 human activities that can negatively impact a watershed quality, and that can be found in your 1.1 notes and the presentation for those notes. And then we have 9 and 10. 9, which one of the 3 points, Eagle Point, Lake Hill, or Deer Ridge, provided runoff to fill Oak Run River? If you're not sure, use the pipette. So I'll show you on this one. Where do you see the water going mostly to the river? So here is Eagle Point. Here is Lake Hill. And here is your Deer Ridge. So again, there's Eagle Point, there's Lake Hill, and there's Deer Ridge. Which one do you see supplying more water to the river? And then 10, which of those provided runoff to fill Canyon Lake? So you can rewatch that to see which one provided the most runoff to Canyon Lake.